Welcome to Act 3 of the video. This is when we get into the exciting bit, where we're entering in prompts, editing parameters, and generating images. This is where most people want to skip to right away, and if you skip to this point in this video, I definitely don't blame you, but I do recommend going back and looking at that information if you had skipped it. But anyways, in this section of the video, we're going to be talking about generating images and using the WebUI, so mostly the text to image tab here, but we will briefly talk about these other tabs in a second here, as well as some extension stuff later on. But generally speaking, this section is going to be a general overview of this UI. We won't be going over like in-depth stuff about prompts. We won't be going in-depth stuff about samplers and things like along those lines. So if you would like to see more in-depth information like that, make sure to look up online resources or maybe suggest me making a video about it and we can cover it later. So yeah, interesting stuff though. First things first though, we need to talk about how Stable Diffusion actually works and what it is, because we're going to be talking about how it works in these different parameters and such. And so it's kind of important to know a general concept, which is pretty simple actually. So the idea of Stable Diffusion's text to image, which is what we're going to be talking about here, is the idea that we generate a randomly generated noisy image to where it's just a bunch of noise, random colors, random positions, random ordering based off the seed that we feed it. So the seed down here that we see in our UI. And then that randomly generated noisy image is then fed into latent space for Stable Diffusion. We won't talk about latent space, but basically it's what Stable Diffusion uses to do its calculations and such. It's not actually pixel data. We don't actually know what it looks like because it doesn't actually have a physical form. It's just data, like raw data. So it's not actually an image. And then Stable Diffusion will take that latent data and interpret it based on the prompt that we feed it, based on what we told it that we want to see or what we don't want to see. And then it samples that data over a period of steps based on the parameters that we set to then generate an image in latent space. Then that latent space is then translated by the Stable Diffusion VAE file that we would set up at the top here to then generate a pixel-based image that we would then be able to see and see on this right side here. So it's really important to understand those sort of steps because everything that we modify is going to modify how those steps take place, which is kind of important to know. And I'm going to be referencing it a lot as we go through all these different parameters. So just keep that in mind. Now let's actually generate an image. So we're going to be going over this page here. We're specifically going to be talking about text to image. So we're going to be entering in a prompt. We're going to be editing our parameters, talking about what each one does, and then we're going to be generating an image based on what we've entered. And we're going to see how it goes. I do have a preset parameters that I've set here just to make sure we can actually get stuff that I can use for examples and stuff like that. But if you follow along, you should be able to generate this same exact image that I end up generating over here. So first off, let's go ahead and clear out our positive and our negative prompt just to reset the stage here. And let's go ahead and go in the top left for our Stable Diffusion checkpoint. And let's go ahead and select Spirit Mix Soft and Cutesy that we had already downloaded and installed earlier. Now, if you install or downloaded another model and you prefer to use that one, go ahead. You just won't be able to follow along exactly, and the results that you get might not be what you expect. And so keep that in mind that different models behave differently and they will produce completely different results. And so yeah, if you don't follow along or you don't want to, feel free to select whatever model. It doesn't really matter that much. As long as you understand the basic concepts, I think you'll be fine. But we are going to select the Spirit Mix for the sake of this video. And then over on the VAE, technically it has a baked in VAE, so you can select none or automatic, and it will use the baked in VAE, preferably anyways, unless you've messed with your settings too much or something. And then it'll just, automatically look the colors that it weighs or wants to. And then basically, instead of doing that, I am going to select CuteVAE.SaveTensor, which is actually the VAE that is baked into the model. And so I'm just going to have that up there for simplicity's sake. You can select any VAE you want. If you downloaded a custom model and that's not the Spirit Mix and you want to use a different VAE, go ahead and look on that page where you downloaded that model from, see what they recommend for the VAE. It might already have a baked in VAE, so you could probably do none or automatic and it will automatically do that for you. Yeah, so you don't have to really worry about that. For clip skip, we're just going to set 2. That's what this model is done off of. Again, if you downloaded another model and you're using that one, check the page, see what they recommend for clip skip. And then ETA noise, we're just going to keep it at 0 to keep things simple. And now at the top, this is where we get into what we're actually doing here. So this top box here is the positive prompt, and the next box is going to be the negative prompt. The positive prompt is telling Stable Diffusion what we want to see. So we want to tell Stable Diffusion the type of image that we want to generate and the subjects that we want inside of it. So basically, you're going to be looking at things the way that models are kind of trained, as in they're trained with images that are tagged with various types of stuff. So generally when I'm doing a positive prompt, I try to think of the tags or descriptions that images that I'm trying to generate would have. So it's pretty straightforward, but if you don't really necessarily understand how Stable Diffusion works or tokens, it might be a bit confusing. But with enough experimentation and just looking at examples of what other people have generated, it becomes second nature when you get into this. So for this specific model, there's a couple of keywords that actually work pretty well. So first off, we're going to do best quality, which basically, if the data set had multiple images, there might be like a best quality, a worst quality, that type of thing. If we type in best quality, it's more likely to give us data that was referencing the images that had the best quality version rather than the ones that had the worst quality version. And we'll get into that when we get into the negatives. So we've got best quality here. We're also going to do highly detailed because I like highly detailed images. That makes it so it adds a little bit more detail into the image and such. And then we're going to do detailed backgrounds so that it actually puts a lot of detail into the background as well. There we go. And now we want to think of a subject. Now my preset here has a female in heavy armor with very long hair. So we're going to do female, heavy armor, and then very long hair. Now you'll notice that I'm putting a, what is it called? Apostrophe? That's not right, is it? Wow, I feel like an American right now. All right. Anyways, you'll notice I'm putting the dot with the slash down at the bottom, and this is separating these different words. So the way Stable Diffusion looks at things is it looks at words not as actual words or phrases. It looks at them as tokens, and these are what would normally be called either blanks or spaces. And so the idea is that I'm separating the different types of tags or information that I want to do so. And let's say I wanted to describe things instead. I could say like a female in heavy armor with really long hair. You know, I would do that as a single phrase, and that would be describing one element that I want to see. So in that case, it would be describing a female in heavy armor with really long hair. But when I do these tag styles, I'm saying I want female, I want heavy armor, and I want very long hair, not necessarily all together. Now, the way that you use your prompts is going to vary on person to person, model to model, and which ones respond better or worse to different types of prompts is going to vary. So it's a lot of experimentation and personal preference. I personally use a lot of tag style data, but if I'm using like realistic models or newer 2D or 3D type or 2.5D or 3D models that end up using a lot of realistic data, I might do like sentences and things like that, but you don't necessarily have to. They do mix and match pretty well, and you can get good results either way. So just to point that out. So what I'm doing is I'm separating different types of elements that I want to see. So there we go, just to describe that. And then let's have her have curly hair, because I like curly hair. I have curly hair. It's quite beautiful. And then let's have her have blue eyes and, I don't know, like a blue dragon. No, white dragon. That's better. Yeah. There we go. Blue eyes, white dragon. That sounds familiar. And then we're also going to, let's have her in a forest and make it dark and maybe add some mistiness. So it adds like this fog. Like this image already generated kind of a misty image, but we want to make sure that actually shows up. So let's go ahead and add that in there as well. So there we go. So that is our prompt. Hopefully I typed that all in right so it ends up being the same. All right, so this is the positive prompt. Like I said, we're trying to tell the AI what we want to see. Now there is some nuance here. We are going to go in a little bit later when we actually generate an image. But the general idea is that you want to type in what you want the AI to generate. Now we're going to the negative prompt. This is the opposite, to where we're telling the AI what to ignore or what not to generate. Now, typically speaking with the negative prompt, you want to avoid making the negative prompt very long. You want to be very, very sparing on your negative prompt, because anything you put into your negative prompt will try to be removed from the data set. So for example, if we did heavy armor, but then we also did like greaves or pants or something along those lines, it'll try to remove that data, which means it won't actually generate heavy armor with pants or greaves, which some people might prefer that. But speaking along those lines, sometimes you don't. So if you end up typing in a bunch of negatives, you may not actually know what those tokens represent. So for example, if I type in shirt here, it's going to do anything that associates with shirt, which could include things like blouses or dresses or even heavy armor. We don't necessarily know what the AI has interpreted shirt to mean, and it could cross-reference different data to say, oh, a shirt is very similar to a blouse, so doing a shirt would reference a blouse as well. But if we have shirt in our negatives, it might remove elements that would come up if we typed in blouse to our positive prompt. So that gets really complex. We won't go too much more in depth on there, but generally speaking, you want to avoid as many negatives as possible. You want to do limited numbers of negatives for things that you know you definitely don't want. Now for this example prompt, I did low quality. So we're going to avoid low quality images. So any image that was in the training set that was marked or tagged with low quality, it will avoid using that data, or at least try to. So that's going to be good. We'll also do worst quality. These are just some general tags that I end up adding into pretty much all of my generations. We're also going to do text, logo, because I don't want stuff from other artists. So we're going to do text, logo. Just to be clear, Stable Diffusion doesn't just copy images that was trained with. It's very extremely difficult. You would have to actually specifically try to get those images, and you would have to know about the training set to begin with to be able to do so. Because some people say that Stable Diffusion just copies images. It doesn't. That's not quite how it works. We will get in depth into that right now, but that'll be for a different video in the future. So if you're interested in that, make sure to subscribe. All right, so watermark is going to be our next word. And then signature, because signatures we don't necessarily want either. Username, and then link. So there we go. And that should hold us over for that. I did add an extra colon there. Whatever, is it called a colon? I should have looked that up before I started recording, because apparently I'm dumb and don't know English. Anyways, so now we've got our positive prompt and our negative prompt. So the positive prompt, again, we've told it what we want to see, and then our negative prompt, we've told it what we don't want to see. And we don't want to see low quality, we don't want to see the worst quality, we don't want to see text, logo, watermark, signatures, username, or links in our generated image. Now we will add a little bit more to this as we go along, but first let's go ahead and go down to our generation parameters. Now, sampling method gets complex pretty quickly, but it's basically how the Stable Diffusion is fed the noise from the randomly generated noise image that we had previously. And different types of samplers have different types of sampling schedules and generate different types of images. We're going to use DPM++ 3M SDE Keras. This is one that specifically works really well with this model. Typically, when I made this model, it actually worked with SDE Keras pretty well, and 2M SDE Keras. We won't talk about specifically all these, but I do want to mention that there is a thing called ancestral samplers, which is going to be ones like this Euler A or DPM2A, the ones with the A suffix. Technically, ancestral samplers are not deterministic, which means that they generate a different image each time. The differences can be extremely subtle, and certain models will actually resolve to a point to where it doesn't actually show that randomization. But what ancestral samplers do is they add random noise between each step, which may actually desync with the selected seed that you put down here, which means they may have non-deterministic results. Depending on the model and depending on your setup and stuff, sometimes it will look deterministic, but there might actually be a micro changes to the image. And I've run into a couple of people where like they'll try to generate an image of a galaxy or whatever, and like one of the stars will be slightly off or whatever. So it's not always like a major deal, but do keep in mind that that makes it non-deterministic. So I typically don't suggest using ancestral samplers. There's plenty of samplers to use before that. But we're specifically going to be using 3M SDE Keras of the DPM++ sampler tree. So go ahead and select that one there. Editor cut here. For some reason, I forgot to mention that I'm not necessarily recommending DPM++ 3M SDE Keras, long freaking name, sampler for all models or anything like that. I'm not saying it's like a generally good one. In fact, it ends up being kind of the opposite. It kind of sounded in this video when I was editing it that I was kind of like recommending it as like a default. I would not go that far. I think for a like default, if you just want like a safe sampler that works pretty well across a large number of models, in the newest version of Automatic from the time of this recording, DPM++ 2M SDE Exponential seems to be the best from my experience. So the Exponential is not actually a sampler on its own. It's actually a change to the DPM++ 2M SDE sampler itself that changes the scheduling in a way that's different than Keras. And it was a setting in the Automatic WebUI's settings panel already. But I like deterministic results, so I didn't want to have to go into the settings panel and change things, and I didn't want other people to do so or need to do so in order to replicate my results. So long story short, I hadn't really played around with it until, well, editing these videos. And so I kind of recommend using that one quite often, or you can fall back onto DPM++ 2M SDE Keras, which also does pretty good results, especially with like realistic subjects and stuff. But I just wanted to mention that real quick because I didn't want it to seem like I was recommending this specific setting. And that's true of most of these settings, but I think I do a better job of trying to explain the differences and caveats depending on other settings. I just didn't explain the sampling method enough because when I tried to in one of these recordings, it ended up being like 15 minutes of explaining just the sampling method, which I don't think anybody's really going to be interested in. So we'll do that in the further video. Anyways, back to the normal video. Sorry for such a long edit here. For the sampling steps, we're actually going to turn this down to 34 so that you guys don't have to sit here and generate an image forever. Sampling steps is basically, I was talking about how Stable Diffusion takes various steps of whatever your selected parameters are and uses that sampler to then go over and over and over again. And we can actually do an example of this real quick. Let's go ahead and set up our other parameters real quick as well. Did I do this 512 by 512? I do not remember. 1 second. I think it was 512 by 512. I don't see where it is in the signature data because I can't freaking read apparently. No, I did not. I generated it 768 by 768. So I guess we're going to keep 768 by 768. If you're on lower end hardware, you might want to change this to 512 by 512. We'll talk more about width and height in a minute. I just wanted to double check that. I forgot about that and didn't adjust for that in my sampling data. So anyways, let's go ahead and generate this image and let's just go ahead and do an example. I'm going to go ahead and copy over the seed that I did for this specific generation real quick, but we'll go ahead and do that. So the seed that we're going to enter is 312222427. There we go. And yeah, this is just a preset gen that I already had. Make sure everything else is accurate. Yep, we are good to go. Okay, so basically if you have everything set exactly like I do here, you should generate the same image. But to exemplify what sampling steps does, if we go ahead and generate this image at 34 steps like we were going to, we will get this image here. But this is the final resolved image. But if we actually reduce this to say, like, let's say we do, like, does it generate with 2 steps? I think it'll do 2 steps in Keras. Yes, it will. So we got a complete mess, right? So what it's doing is we already fed it a bunch of noise, right? And it's trying to interpret it, but it only had 2 steps to try and interpret it. So it goes over and refines it every single step. So if we do 2, we get this weird kind of meshy image and it looks really noisy and gross and such, right? And then we can go to like, let's say 5. And then regenerate the image. And it's like, now it's really messed up, but we can start to see the female figure here. It's starting to get like the dragon aspects. It's starting to get the heavy armor a little bit in here. And we can start to see what it's trying to figure out. And then if we go to 10, go ahead and generate that. Now you can see it's like, okay, female, dragon, it's got different concepts and stuff, but as you can see, it's also drastically changing the image in ways that may not be expected. Your sampling steps can actually generate different images based on how far it goes, based on the sampler. SDE generally resolves to a single image in the long term, which is why I personally like it. But yep, and then we'll just go to, let's just go up to 20. So we start actually seeing the conclusion, because I think you get the idea now. So now we got a female character, and then let's go ahead and go all the way up to 34, or let's just go ahead and go to 28. So as you see, like the farther we go, the different of an image we get, and the more resolved it ends up getting in the end. So for example, you see this dragon here, and now the image is starting to look, you know, pretty resolved and such. It's starting to look like a proper image. It doesn't have all the artifacting and stuff. And then 34 is typically what I recommend on this model, and that's when it refines to this final image. But we can actually go farther. So for example, we can go to 40, and go ahead and generate that. And as you see, it even added a dragon over here. And again, go to like 48 or something like that. And now it's refined it even farther. It's gotten rid of the dragon head. It added the tail over there. So your sampling steps will change the way the image generates, but you can definitely see how it interprets that noise and keeps continually interpreting it. Now, one of the things about this, however, if we go ahead and go to our image tab here, so if we start up at the beginning, we'll see that it changed quite a bit as we went along. So, you know, it had the same general shape in that center, and then it started to go into it and generated the character, and then it has the character. But as we saw here, it ended up changing the position and the environment. Now, I typically refer to this as called inverse noise. It's normally technically called an artifact, where basically we've added so many steps that it starts interpreting the normal image as noise. So the dragon head over here, for example, wasn't actually interpreted as part of the image, and it was interpreted as noise. So when we did more steps, it actually removed the dragon. And it would continue to do so, and it would continue to interpret different things as different objects. Now, if you go to enough steps based on the sampler that you use, it might eventually resolve to the same image and kind of look the same as you go along. But how it changes and how it affects the image is going to change based on the model that you're using and the sampler. So keep that in mind. And it's fun to play around with. You can see what you personally like. I typically try to go to a certain number that ends up looking like a good resolve without too much inverse noise and too much alterations to the image itself. So for example, this one, The lady's in the middle like it was for the low noise image, and it's got the same general composition, which is generally what I aim for when I look for the right sampling steps. But you can increase it or decrease it as you feel is fit. So that gives us a general idea, and we've got our generated image here. Now let's go ahead and mess around with the other stuff here. Now we're going to talk about width and height first, and then we'll go back to high-res fix. So width and height is basically what the image you're going to feed Stable Diffusion at first. It's going to be the random generated size of the noise image that you create, and it's going to be the image that it outputs. And keep in mind, if you change the size of the image, you're also changing the noise footprint, as in it'll generate a different image. So if I generate this as like 769 instead of 768, even though it's a nicer number, it'll generate a slightly different image because the size has changed. Now, some small changes don't actually change it a whole lot, but if I go up to like 124, I'm not going to get the same image, but like stretched, for example. Like let's do 1024 by 1024. You don't have to generate this image. It's going to take a lot of VRAM. It's going to take longer. But as you see, we completely changed the noise and generated a completely different image. All right, sorry about that. I had to step away for a moment and get some water because I just had a little coughing fit. That was fun. All right, stay hydrated, you know? All right, so anyways, let's get back at it. So talking about the width and height will change the noise, but even if you do like a very small adjustment, it'll change the noise ever so slightly. You might be able to find like small little adjustments and stuff like that. Some bottles will affect it more, but since the seed, aka the random noise that we end up generating at the beginning when we feed Stable Diffusion, is done in like a linear fashion, small changes in height and width might not change the image drastically. If we go back to the images that we had before, so this one and this one, I believe this is this one and this one, right? You'll notice that they're pretty much exactly the same visually, right? But if we zoom in, we could probably end up finding a small little adjustment or something that's slightly different somewhere because it did change the noise output, which will change the way that's interpreted. Just a little bit of a heads up. So it's a good reminder here that anything you change in your input parameters will change the image output. It might not change it drastically. There are certain small adjustments you could make, but the small adjustments aren't really going to be meaningful to generating a new image. But you do want to make sure you match parameters based on what you're trying to generate. So for example, if you're trying to make something that somebody else made and they give you their parameters, you want to make sure to copy their parameters exactly. And there are certain prompts that you just can't copy because they didn't set up deterministic results like we did before. So you might not get the same results. So yeah. Let's talk more about the limits of width and height. Now, this model specifically does a surprisingly good job at generating images up to 1024 by 1024. And there are certain aspect ratios you can do, but typically speaking, with SD 1.5, you are looking between resolutions of 512 and 768. So Stable Diffusion 1.5, since I coughed, I'm just like way over the place. I apologize for that. Since Stable Diffusion 1.5 was trained on images of 512 by 512, it's going to do best at generating images at that width and height. That doesn't mean that you're stuck to that. And one of the things that's really, really nice about custom models is that they're able to add generated data or other training data into Stable Diffusion. And so basically custom models are able to have higher resolution images. So this model specifically has a bunch of models that were trained on 768 by 768, which means that we can use 768 and generate very high quality images. And since it was, trained at a higher resolution, it can actually even go beyond that. But typically speaking, when I'm using SD 1.5 models, I try to stick it between 512 and 768, and I try to use those numbers specifically. So my minimum will be 512, or if I want to do a higher width, so let's say I want to make a really tall image, I would do 512 by 768, or if I wanted to do a wide image, I would flip these around, and I would do 512 on the bottom for height, and then I would do the width as 768. And if we go ahead and generate this, you can see what I mean. And this would allow us to get a wider image. And it did a dragon this time. The lady is gone. The lady has been eaten by the dragon's existence. All right, anyway, so that's the type of thing that you want to keep in mind when you end up customizing the width and height. But you may be asking, what if I want an image that's larger? Well, let's look at what happens when you try to extend beyond the limits of this model. So let's go ahead and change these back to what they were. I can just hit Control-Z, I believe. Oh, it's not working properly. That's fine. Let's do 1024. And by 1024, and let's go ahead and look at how the image generated. Let's just go ahead and regenerate that. So we have this image here, right? And it's not perfect. It's got some weird issues, but it does look kind of cool, right? Let's go ahead and change the height, and we're going to go up to 1200 instead. And we're going to go ahead and extend it height-wise. And we'll see what it does. And now we're kind of getting some distortions and some weirdness, as you can see. For one, it removed her pants for whatever reason, but you can also see her foot started to turn into a little bit of a dragon. Let's go ahead and stretch it even farther. Let's go to 1400 and see what happens. So when you start stretching beyond the parameters, you start to get artifacts and oddities. And it's like, okay, well now the dragon is completely screwed up and she's really, really tall. It's not messing up in the same way that I thought it was going to, so that's kind of interesting. Different prompts are going to behave different ways. So you can technically do this, but the farther you go, the more messed up it kind of gets, and you get more distortion. Let me go ahead and try to find an example. It is doing a surprisingly good job of this. It's not as distorted as I was expecting. Normally what it does is it duplicates like body parts and stuff. One second. Let me go ahead and look over my test results. I did not save that test result image, did I? I thought I did. Aha, here we go. Okay, here is an example. Oh, I really went extreme with this one. Dang. That is not what we're trying to generate here. So as you can see with this generated image, let's go ahead and try to recreate that actually. So I believe for width, they probably did 768 and then extended it to whatever number we ended up going from there. This is like having fun, just trying to break it. No, it worked well with this seed. All right, whatever. But yes, so sometimes when you extend too far, you can start to get artifacts. So for example, in this image, it sort of made two landlines, so one right here and one down here. And it also ended up duplicating the body parts, for example. So for example, her head became a whole nother body, for example. And that's the type of thing that you can end up seeing. However, it doesn't always end up working that way. Sometimes with certain seeds, you'll actually get generations that look perfectly fine. I wonder if what would happen if we change the seed here. But yeah, sometimes it looks fine, sometimes it doesn't. This one, it turned her legs into a dragon a little bit, or we can end up doing even more extreme. So let's go ahead and go to 2000 here, and we'll go ahead and make it super stretched. Go ahead and generate that. There we go. And now we start to see some more of the artifacts to where now she's floating because it would think the ground is here in the training images data, and the dragon has now her legs, I guess. You know, just basic type of stuff. You can play around with it. You're not stuck to those resolutions, but I do typically, if you're looking for more consistent results, you do typically want to stay within those parameters. So let's go back to 768 by 768, go ahead and generate our image. And that is a completely different image than what we had. Oh yeah, I randomized the seed. Whoops, I need to re-grab that seed. Ha, my bad. As you can see, this likes making pretty ladies, just so that you know. All right, so where was that seed? There we go. I probably should have scripted this a bit better, huh? Not doing a very good job now. After that coughing fit, my brain went haywire. All right, so there we go. Now we're back on the image we were at. So that's generally how that works. But what if you don't want to have a bunch of artifacts and you want a larger image, for example? Let's say that you're trying to generate a specific image on a specific model and it's having trouble going above 768 or 512 or whatever it is that it's trained on, such as 1024. Oh, by the way, SDXL was trained on 1024. We're not really talking about SDXL in this video, but SDXL can generate much larger images because it was trained on images that are at 1024 by 1024 or all those variations. So it's got much larger image space, but it also takes a lot more memory and it's a lot more resource intensive. We won't be talking about SDXL in this video though. All right, so what if you do want to generate a larger image though, and it doesn't work when you just, increase the width and height, right? You can use what's called high-res fix. Now, this is a feature of Automatic's WebUI. There are alternatives in other WebUIs as well, but you'll have to look into those WebUIs specifically. But high-res fix, what high-res fix is, it actually upscales the image using latent space. And this is really, really nice because it allows you to upscale the image without losing any of the generation parameters. And it also allows you to upscale an image using that gen data to then enhance the image you get. And you can use it to either add extra detail. You can make it so that it just keeps the same detail and fixes up a couple of errors while making the image bigger, or you can just make it straight up, just make the image bigger and not really change much. So what we're going to do now is we're actually just going to upscale this image without changing it too much. Now we're going to be using the R Essergen upscaler. So upscaler models are different than checkpoints and VAEs. We're not going to be covering it in this video, but basically if you go over to your Stable Diffusion install here and you go to models, it was the one that goes in the Essergen, and you can see here I've got a couple of models, but Automatic also comes with a bunch of them. So in the settings here, if we go to upscalers, which should be, man, I can't read. I've been recording for too long. So Oh, it took me a second to find it. It's called upscaling, not upscalers. In here, you can actually see that there's a couple that you can enable in the UI, and I have rsrgen 4x plus and rsrgen 4x plus anime 6b enabled, and these are ones that are included by default. I enabled these two because I do personally like them. They're very safe upscalers, so if you go into the settings, you can select these as your upscaler for this specific thing. Make sure to hit apply settings after you toggle them on. But then we'll go back to our text to image, go ahead and select the rsrgen 4x plus here. And then we're going to set the high res steps up to the same amount that we have for our sampling steps. This is generally a safe thing to do. Oops. This is generally a safe thing to do. You can change it higher or lower based on the results you're going to get. If you do latent, higher steps can be better or worse depending on the model that you're using or what you're trying to create. So you can play around with it, but generally speaking, for a safe setup, which we're doing here, we're just trying to upscale the image and make it look crisper and clean up some of the errors without having to accidentally change the image too much. And then we're going to set denoising strength to 0.36. This is going to basically how much noise we add into the image for the high res fix, or how much we want to respect the image. So the lower it is, the more similar to the image we had previously before high res fix we'll get. And then the higher we put it, the more random it'll be. And if we set it all the way to 1, it'll just basically generate a whole random new image. And then upscale by is the scaling that we're going to do. And I'm just going to do 2 times for this example. Generally speaking, I don't go above 2 times, but for modern models, you can actually go all the way up to 4 times, and it generally works pretty well when you use something like rsrgen. But I will say there are different options here, such as latent, which basically resamples the entire image using the prompt. And that can kind of struggle once you go above 2 times. So do be aware that different settings will work better. But for the safe settings, we're just going to select 2. And then for the resize width and height, if you set these manually, it'll use this instead of the upscale by, but we're just going to keep the upscale by. Now you can technically use the resize width and height to try and stretch an image a little bit, but it doesn't always work very well, and I don't typically like the results it gives, but you can mess around with it if you would so choose to. Now, the reason why we select these settings is because they're fairly safe. So if you want a general setting just to use for all of your generations, you can set this setup, and it's generally pretty good. It doesn't actually add say new artifacts or anything along those lines. So if we go ahead and generate this image here, I can kind of show you as an example. So it's going to be a much higher quality image, but it's going to be very, very close to the image we already had. So to talk about what's safe about this, doing the high res steps, I generally set it the same as the sampling steps. I use rsrgen 4x plus, generally speaking, but you can also use the srgen 4x, but I don't believe that's included by default. I'm not entirely sure. I have it in my extras models that I've added in. And then I use the denoising strength between 0.3 and 0.4. Generally, I do either 0.4 or 0.6 or 0.34 or 0.36, and that generally does well. But anyways, let's go ahead and look at the image we generated here. So we've got our previous image and our new image. So if we look at this, oops, that's the wrong one because I accidentally clicked on the next image. There we go. All right, so go ahead and look at this. You can see that, yeah, it's pretty small. It's a pretty small image, but this one is much bigger. There we go. But if you look at the images themselves, they're pretty similar together, but there are a couple of changes that it's made. So for example, if we go ahead and zoom in on the armor here, you can see that the coloration is a little bit different. It's got more of a painterly texture over here, and it's got, different highlighting and stuff like that. But the major difference, for example, is going to be smaller details like these ones. It tried to resolve it better. This one kind of looks, a little bit messy and stuff, and this one tried to resolve it as if it's like a crystalline type of thing. So there you go. That's kind of what it does. But it does a good job overall of making the image look relatively similar. So for example, if we, it won't actually let me zoom out farther than 100%. There we go. If we make them similar or whatever, they look very similar, but this one's going to be much more refined and look more resolved than the smaller image that we generated before. So that's generally what that does. It does make some small changes here and there, but generally speaking, this setup does kind of correct errors. So if you're looking for a general use case, that's a good one, but you can go ahead and play with it. For example, if you want to make an image that has a bunch of added stuff, you can go into latent and you can actually mess around with that. I believe 5.5 or 0.55 is good, but I'm going to do 0.5 just as an example. But latent can also be pretty cool, as in it can add a bunch of data. If you do it too low, it won't really do anything, and you might actually start getting artifacts. So for example, 0.5 I don't believe is low enough, but as you see, it drastically changed the image, and it actually changed some of the resolve. So we'll let it finish generating here. Just come on, let's go. Woo, woo. Sometimes I wish I had stronger hardware, but I can't get stronger hardware. But as you can see, it actually slightly changed the image when we use latent. Now, because we set it to, let's go ahead and make this 100. Whoop, there we go. Go ahead and make that there. So as we can see, the difference between the two upscalers, gosh dang it, Windows, come on, cooperate with me. You can see that it ended up removing the thing that she was holding mostly. Oh, whoops. Go back. There we go. All right, it removed the thing that she was holding most likely. It turned that little nib bit into a little tiny dragon. It looks like he's like crying for his mommy. His mommy's over here with tiny head syndrome. Like, I'm sorry. I just have to go to the doctor. And that's how it goes. And completely change the scales, completely change the armor. And so latent will actually reinterpret the image entirely. It'll keep the same composition as long as your stuff is low enough. But if you go too low, so for example, if we go down to like 0.2, for example, instead of actually getting an upscaled image and getting it resolved, you'll end up start seeing artifacts. And this also happens if you go too high as well. And we'll go ahead and exemplify that here. So as you can see, the image all of a sudden is getting really, really weird looking. It's going to be really, really blurry, and it's going to have some like oversaturated lines and such. And that's because it's trying to reinterpret the image, but it doesn't have enough freedom to change the image in the way that the sampler says it should. And as a result, you end up getting this really blurry and messy image. And different models and different samplers will have different artifacts, and you'll start to learn what those are as you mess with these different samplers. But if we go ahead and go all the way up to 100 though, or 1, it should go halfway through generating the image that we see and then generate something that's somewhat completely different. Or will it? There it goes. Yeah, so it just completely generated something completely unrelated once we set it up to 1. So finding a good balance for whatever sampler you're using will be good. But if you set it too high, for example, we're going to see those artifacts that we were seeing when we ended up putting up the width and height way too high, for example, such as the dragon having the wrong feet, duplicate limbs, wrong positioning, duplication, that sort of stuff will end up happening. So typically speaking, for latent, it tends to vary on the model. I generally go with 0.55 on this model specifically, but sometimes it's higher at 6.5 or 0.65, or sometimes it's lower at 0.4. It really depends on the model and how it behaves. Generally speaking though, 0.55 is a good safe bet for latent. It generally doesn't have too many artifacts, but some models struggle with it, so you might have to turn it higher or lower. So there you go. But yes, so let's go ahead and reset our setup back to the way it was. So that was at 0.36. And that should describe high-res fix. And high-res fix is incredible, by the way. It is probably one of my favorite things about the automatic WebUI, and it's something that I can't give up. It's like an addiction. The ability to use latent space to regenerate images is fantastic, and it allows you to do a lot of really creative stuff while generating high-quality images. Now, if you're talking about making images even larger than 2 times or 3 times, like I was talking about, and you start running into artifacts, you can try lowering how high you're upscaling it, and then that's when you would go into the extras panel and you would start using the various upscalers. So you can select those same upscalers here, select a second one even, and kind of mix and match them, and then change the visibility of the second sampler. So basically the different upscalers will be able to generate larger images. However, this extra tab works in pixel space, which means it won't generate based off the latent space, and it won't have that generation data to do it so. So you end up getting more artifacts and different types of visuals based on the upscaler you use. But you can use either one depending on whichever type of image you're using or how the results end up turning out. But I highly recommend trying high-res fix first. High-res fix is more intensive, it does use more memory, and it's going to take longer to generate, but generally speaking, if your hardware can handle it, it'll generate much higher quality images. So there you go. Generally speaking, I always generate with high-res fix, but for the sake of this video, we'll go ahead and eliminate it from now. And then down here, we got CFG scale. This is how much you want the Stable Diffusion to respect your prompt, for example. So it's how much weight we give to our positive and negative prompt and how creative we want the AI to be. So for example, if we go lower, it's going to respect our prompt less, and it's going to just randomize the image more, and it's going to be more free within the data that it pulls from to then generate images. Whereas if we go higher, it's going to be much more strict towards the prompt, and it's going to be much more strict and deliberate with the data that it pulls. Now, how this works specifically and what it does to images is kind of hard to explain on a technical level without going super in depth about it. And we're already going over time for this video, so I'm not going to talk about it here, but generally speaking, you want to try to find a median range. What I recommend for Stable Diffusion 1.5 is somewhere between 7 and 11. Those between those numbers, depending on how much you want, 11 being the high end, 7 being I want the AI to be more creative, is generally what I do. So I'll go down to like 7 when I'm trying to test a model or something along those lines, just to see what type of data the model has and what it will pull from. You can even go lower if you want, but don't go too low because you'll start to get artifacts. Same if you go too high, you'll start to get artifacts as well. We won't show that off here because it's kind of pointless. But then if I want to specifically design something and I find that my usual, which is about 8.5, 9, ish, then if I find that that's not enough, I'll end up going up to 11, and just to try and force it to respect the prompt better, just to see what it does. But figuring out the right CFG scale for what you're trying to create requires a bit of experimentation, and there's generally other ways to modify your prompt and such. So generally speaking, you'll find like a good middle point for that model or that specific type and that type of prompt, and then you'll use that and then modify your prompt and other parameters to try and get what you want. So just to speak on that a little bit, but we won't be showing too many examples there. And then the seed is just the seed we use to generate the random noise that we feed Stable Diffusion. Quick editor note, I think I forgot to mention what the dice and the recycle button do over next to the seed. So the dice button actually says it to re-randomized. If you set the seed to -1, it will re-randomize the seed every single time you generate. However, if you select one of the pictures down at the right side underneath where it shows like the images, normally if you generate multiple images, it will show all of them there. And so you select that, and then you're able to hit the recycle button, and that will actually put the seed from that image into your seed prompt. And then there's a small extra tick box that allows you to do some other stuff that ends up messing with the noise generation and the seed and how it behaves. I typically don't mess with it. There's not really a reason to, but some people are skeptical about it and like have some ideas about like, oh, if I do this, it's like better and stuff like that. It's just interesting ways that you can mess with the math and like try to figure things out and do advanced stuff. And maybe there's some cool stuff that we don't really know about yet. You never know. Just go ahead and play with it. Anyways, back to almost the end of the video. So now that's kind of the general overview of what everything is, giving a little bit more technical details on what each of those do so that you can kind of understand what they all are. There is one tab we did skip here, which is called the refiner. The refiner is used specifically for SDXL and certain models. We're not going to cover it in this video, but basically it allows you to run a second model on top of the previous model to then refine the image. And that's why it's called a refiner. And I typically don't use this. A lot of custom models for SDXL do not use a refiner. And there's some creative stuff you can get into when you use refiners, but I'm not going to cover that in this video because that's far beyond our scope currently. So if you're wondering what a refiner is, it's technically for SDXL. I think you can use it with SD 1.5. I haven't really tested it much, but it doesn't really give results that I liked. So yeah, so there you go. And I haven't used the refiner in Automatic at all. I've been using it in Comfy UI, which is another web UI I use. So yeah, I don't know how the refiner works in Automatic quite yet, so I haven't experimented with that. But now let's actually try to talk about how to specifically engineer your prompts a little bit and get more advanced techniques and what we can actually get into. And this is going to be where I'm going to do another cut point. So I lied about the Act 3 being the final bit. Don't worry, we've got a prologue coming up. So, well, wait, is it prologue or is it end log? Wait, what's that term? No, don't turn off the recording. Editor Michael here doing an outro because I hit end on the recording and it took a second to process, which is why you hear me get upset. That sounded dumb. Anyways, thank you guys so much for watching. Make sure to like, comment, and subscribe for more content like this one. And of course, check out our Discord. I keep calling it a gaming Discord. It is actually a community Discord now. Link in the description below. And you can also end up donating to my work on the Kofi and stuff. I'm really tired and I'm editing this video, so this outro isn't going to be too exciting. I'm sorry. That's it. See you in the next part. The next part's lazy. Next part's lazy. It's fun though. It's got some good info, so check it out.